What's up, guys, and welcome to Manic Analytics. In the last video, we talked about model evaluation, and so we were able to evaluate our trained model, and by that, we were able to find out that our model was working quite well based on the evaluation metrics that we discovered. As you can see, that the accuracy got an accuracy of about 92%, a precision of about again 92%, with a recall of again about 92%. You can see the F1 score. This is the weighted F1 score, and you can also see the receiver operating characteristics. Again, this was the weighted score as well as the precision recall curve. Again, about 95%. So you can see that our model is working quite well based on the evaluation after doing the training. So today we are going to handle the model validation, and under this we are going to validate our model using a new set of data to see if it performs according to what we do expect. So we do expect that the validation to be quite close to what we are seeing under the model evaluation. So we don't we shouldn't be expecting a significant deviation when we look at the metrics for the validation and when we compare those metrics to that of the evaluation. Okay, so basically that's what we are going to be discussing. And again, to add on that, we will be tracking our evaluation artifacts using MLFlow. Okay, so that's what we're going to be discussing today. It won't be something very much intensive. So it will be just something, most of the things will be just lifting from model evaluation. So that's what we're going to be discussing today. So once again, I'm Western Onzere, and this is Manic Analytics, where we show you how to build, deploy, and monitor your machine learning and AI systems in production. Subscribe to the channel if you haven't yet. Like this video, and let's get started. So as usual, we are going to start with setting up the configuration parameters. So we are going to the step, I think this will be the last step, and this will be the model validation. So model validation. Under the model validation, so we will be specifying things like the common things. So we are going to create a root directory for this. So root directory, and this will be artifacts model validation. Then we will specify the model path. So artifacts model trainer, then model.joblib. So that's okay. So that is the path to the model. So we'll be importing the model, then doing the validation component. Then we'll be again the test data for this. So I'll just say state test data path. So for the data path, I will be specifying now under the data transformation. We were able to split our data into training, testing, and the validation set. So this we are going to import now. Copy. We're just going to import the testing data. Okay. That's okay. So artifacts, data transformation, next test data. So that's the testing data. Then the test target variables. So the test target variables. So test target variables, again the artifacts, data transformation, and this will be Y test. So that's okay. Then we are also going to create a metrics file. So for the metric file's name, instead of evaluation, it will be validation metrics.json. So it will be validation. Then after that, we are also going to, since we are going to include, we will also include this, supposed to be Churn, if I'm not wrong. It's supposed to be this MLFlow URI, so that we are able to track this artifacts, this one, these validation results. So you're able to track those with MLFlow. So this, I think by this, that's all about setting up the parameters. So we have set up the parameters for model validation. So let's jump into the trial and generate or write the code for model validation, how we are going to validate our model. So as usual, we're going to start by importing the libraries. So these are the different libraries that will be libraries and modules that we will be using. MLFlow Dagshub. We're also going to set the tracking URI and initialize the Dagshub. Okay, so for Churn, I think this one is okay. Yeah, I think this one is good. Supposed to be just need for that. That's it. Then after that, we need to set the configuration parameters. So I'm going to set the configuration parameters. So we can just say this is the model validation entity. So model validation entity, and we can just say equals use the data class decorator. So data class, and then we create the class model validation config. So class model validation config validation valid. So model validation config, then whatever we specify here, we can just copy this. Then we can just specify under the model validation config, make sure the alignment is correct. And then from this one is just a file path, and then I can just copy this, then I replace this again with the file path. I think everything will be path. This is the path to testing data. This is the path to how we are going to set then this one will be just a user string. Then this is the MLFlow URI. Then we also need to include the target column. Target column here. So we have the target column metrics.phylum. Then we have the MLFlow URI, the testing data. Those are the input features, and this is the target variable. Then the root directory. So that's okay. Then the next thing obviously is the configuration manager. So if you have been following through, I think you understand how we were creating the configuration manager. So it's not something new. Then now we can just paste that here. So this is the configuration manager. Then configuration manager. Then we can just do this. So let's set these arguments in a new line. So this is the configuration manager. Then now we are setting this method so that we are able to create read these different YAML files, the config parameters and the schema. Okay, then we are also going to create this directory using this method. So this method is going to be used to perform read these YAML files from the different paths that we have specified, as well as create this directory under the artifacts. So we are in the model validation. So create a directory and artifacts with the name model of a model validation. So that's it. So I think everything is now set. Just whatever we are using here should be everything that we have specified under the entity. the configuration parameters. Okay, so root directory, model path, this data path, then target path, metrics, file name, target name, and MLFlow URI. Then we return this object. So after this, we then create the class to handle the model validation itself. So the class model validation, class model validation, and dev init config model validation, then that's okay. Then we create a function. So this function to make the predictions. So dev predictions, we are going to say then the model x test transformed x test. So this is the training features. These are the training features, input features, sorry. Then when making predictions, y predictions, model will predict on the training data, the testing data. Then because you are going to plot again, create the roc curves, so that the receiver operating characteristics as well as the precision recall curves. Then we do need the y prediction prober. Then for this method, these are the things that we are going to return. And after we are done with that, we are going to now do the model validation. So dev create a new method for that, model validation, self, then y test, y prediction, and the y prober. Then after this, we calculate the evaluation metrics. Calculate the validation metrics. Metrics. So this one can start with the, for example, accuracy, the precision, the recall, the F1 score. So accuracy, the accuracy score. So we are using the accuracy score function from, I think this one, accuracy score function. This one is coming from the scikit-learn.metrics. Yeah. So we are calculating the accuracy. Then we are also calculating the precision, then as well as the recall score, recall. So for the precision and recall, we are finding the weighted precision score for the recall as well as the F1, because this is a multi-class classification, and each class will contain its precision value, recall value, F1 value. So to avoid tracking all those values for the individual classes, we just use the weighted, for example, precision for each weighted precision value. The recall, again, we just use the weighted. The average, again, we can, sorry, for F1, again, we are using the weighted. So there are different things. There are different parameters that you can use. You can use either the micro. I think the micro will print the different. For example, it will print the F1 score for each class, but macro is mostly used when your class don't have an issue with the class imbalance, and weighted, I think, is for if you have an issue with the class imbalance, so you use the weighted. Binary is just for the binary classification if you have only two classes. Okay. So then to add on that, we're also calculating the receiver operating characteristic curve. So that's the roc curve as well as the precision recall curve. So as I said in the previous, when you are dealing with the model evaluation, is that I like including this evaluation metric as much as possible. So just including any evaluation metric that will suit our model, so that you make your code scalable. Then so that in future, when sometimes your precision recall curve will hold more information, just in case when it comes to a point where you are dealing with the data that has severe class imbalance. But right now it's moderate, then we might prefer the roc the receiver operating characteristics, aside from the accuracy, the precision, and the recall and all that. Okay, so that's it. Then after this, we can print a detailed classification report for the confusion matrix. Then we return this matrix. So we can just create that, print a detailed classification report and the confusion matrix. The classification report, the y-test and the y-pret, then confusion matrix. Again, we are just printing that. Then we return the evaluation metrics, accuracy, precision, recall, the F1 score, the receiver operating characteristic, as well as the PR. Then after that, what follows next is plotting the PR, the precision recall curve, as well as the receiver operating characteristics. So I'll just include that, just as what we did during the model evaluation. So this is the method that will help us plot the receiver operating characteristic curve. So at first thing that we need to do is to binarize. Then after that, you just plot your curve. Again, for the PR curve, you binarize because you are dealing with a multi-class classification. Then you plot your precision recall curve for each class. So that's it. Then after that, we need to now save and track all those metadata and artifacts that will be produced under the model validation. So I'll just produce the code for that. So it's not something that is changing significantly. So we are going to save our results. Let me make sure the alignment is correct. Just try to squeeze this, make them scroll, make sure these functions are aligned properly. Yeah, I think this one is okay. Yeah, I think this one is okay. I'll just increase the font. So when it comes to so we are saving the results from the predictions. So these are the scores. You can see the accuracy, precision, recall, F1 score, roc, and the PR curve. So we are saving this, calculate and save the evaluation metrics. So we are saving these results. Then after that, we just track those results. Then for the roc and the precision curves, again, we are saving those. Then I think we are tracking those. So we are logging those as artifacts in our in MLFlow. So after that, we need to prepare the main block. So for the main block, so this is the main block. So we initialize the configuration. Then we load the model as well as the data. So this is how we load the model. Then this is how we load the data. So this is the testing data, and this is the target features or the labels, in other words. Then we validate the model, so model validation, and then that's it. So basically, this is something like a pipeline that is going to tell us which steps we are going to follow so that we are able to validate our model. So I think by this, everything is good to go. As you can see, it's not something very complicated. It's just something simpler as to what we did with the model evaluation. Okay, so I think this one is it. So the only thing that we need to do is to execute this and see if we are going to get a result from this. So I'm just going to open the new terminal. Then just execute this code snippet. So model validation. I'll just copy relative path, and then can paste it there. Then press enter and wait to get the result from this. So this is the model validation. Then after this, I think the next step we'll just prepare. We are getting some error metric file path from this one. So there is an issue coming from constant config file. So we don't need the metric file path. So I think it's coming from the constants. So e.py, yeah, I think we don't have this, so we don't need it. I'm just going to run this again. So as I was saying, we are in the model of, I think this is the last step, model validation. Then after this, we are just going to prepare the prediction pipeline, and the prediction pipeline will enable us to handle user input. So we need to get the user input, pre-process that input data, as well as in a similar way that we processed our training data. So I remember under data things under data transformation, yeah, we had this preprocessor object. So we are just going to attach data with this preprocessing object, and it will preprocess that user data this in a similar fashion that we used to process the training data. Then after that, we'll import the model, then do the predictions on that data, and then it will display the results to the user. That's what we are going to be doing, and so that's what we are going to be doing under the prediction pipeline. So we are getting another error. Object has no attribute predictions. I think predictions. Where is it? Supposed to be predictions. When you go to this model evaluation, it's supposed to be predictions. Just a slight typo here. So after this, we just make sure you have saved it. Then we execute this again. So I think it's running okay. Then I think it's running okay. What we can just do, let's go to Dagshub, so that we can see if we are tracking the model, if we are tracking the model validation. Let's go to Dagshub. I think this is the one that I'm using. Churn prediction. So if that is done successful, we'll see that is successful. Then we'll see the results in MLFlow stating did we provide a name? Should have provided a name while doing the tagging. So this is the model validation. Yeah, I think we provided a name for that. Objects, precision, accuracy, precision, and recall F1 score. Model validation attributes, no attributes, model validation. Why are we getting this? What are we missing? What are we missing? What are we missing? What are we missing? You can see accuracy, precision, recall, F1 score, roc, PR curve, self-load model validation, y-test, y-pred, prober. You can see save results, self, y-test, y-pred. Then this one is saying attribute error, model validation objects has no attributes, model validation. So what maybe we have forgotten to add something. Self-load model validation, y-test, y-pred, y-prober. Then run name model validation. Config model validation config, model validation test data, model validation test target variable. That's okay. Validate the model. I don't know why we are getting this. Unpred BPM classifier. Yep, let's try this again. Supposed to get a result from this. I don't know why we are accuracy precision. Again, now this, you're not supposed to have this here. Yep, that's okay. Configuration class. Then get variable MLFlow URI. Then should be getting an output from this binarize as unique y test y prober. Then that's okay. Also fine. Accuracy precision recall one score. Yeah, I think now we are getting a result from that. So you can see the end is that we are saving this validation metrics.json. Then here we can see we are having the model validation. You can see the precision recall have as a PNG file. So it's almost closer to what we were getting with the during the evaluation. So you can see there's not much difference. So you can see that our model is generalizing well. So when we go to our experiments, so we can see that we have experiment 12. This should be the latest one, the model validation. This one, the model validation. So from here, we were not tracking the parameters. So that's why they are not showing here. Then these are the metrics, accuracy. You can see F1 score, PR, precision, roc curve, the recall. You can see we are performing, it's not bad, it's not bad off. Then for the PR curve, you can see class 0, class 1, class 2. It was, I think, 92 in the model evaluation. 96, about 96, yeah. So I think it's not bad. It's not bad for the model validation. So I think that's it. That's it with the model validation. So the only thing that remains is to convert this into a modular coding structure. So we are just going to separate this into their distinctive units. So starting with the entity. So I'm just going to copy that. Then inside entity, we have config entity. Then this was for the model trainer, model evaluation. To be model evaluation. Then this one we set model validation. Just copy that. And I think that one is safe and sound. And the next thing is about the configuration manager. So we just interested in this config manager, config this one configuration. Then and just make sure we have introduced this function. So this is for the model evaluation. And this is for the model validation. That one is good to go. The next thing is components. So I'll just copy everything. Then model validation component. Then I'll just paste it here. Then I'll do away with this. It will form part of our pipeline. Then the whole of configuration manager and the entity have to go. So I just remain with the MLFlow Dagshub tracking URI. Then this one you can see it is irrelevant. Then you can see joblib is irrelevant. PD is irrelevant. And you can see this is also irrelevant. Then you can also save JSON is required. What we just need to remove is this. And, create directories again. We don't need it, and we don't need this decorate. Then I think up to now everything is good. So we just need to import the model validation config. So I'll import it from supposed to be from src .churn dot entity config entity. Going to import. We're going to import the model validation config. Model validation config. I think this one here. Yep, I think that one is okay. Let's cross check to see that we are not missing anything. Yep. Yeah, I think no, there's nothing that we're missing. So if you want also to track the hyperparameters during a model validation, then we can use this log model parameters. So you can also just include this during the model evaluation. So this is model evaluation. So model validation, just need to include this. Maybe is it supposed to be? Yeah, it's supposed to be inside this with conditional statement. So that one. I think when we execute the main.py, you will see that we'll get to, when we just execute this pipeline, then we'll include this in our MLFlow tracking. So I think this one is no problem with that. So component is done. The next thing is pipeline. So we need to go to a model validation pipeline. So I'll just paste whatever we prepared under the. So we import the configuration manager, then from the components, component number 6, model validation, we import our model validation. So remember, this is the actual class that does the validation itself. Then we import our logging, joblib, and pandas. Then we give a name to our pipeline. So that is the model validation pipeline. Then we create a class for that. Then we create a function that will execute our pipeline depending on these instructions that we have provided. So it first initialize the configuration, then they load the model as well as the data because it is necessary for that. Then we do the validation. And I've just included the main block so that we can independently execute this pipeline. So for example, if I want to execute this pipeline, just the model validation pipeline, then I can just go to my terminal, then state Python, then just copy the relative path for this pipeline. So it will only execute the model validation pipeline. So as this is executing, let's go to a main.py and finish this off. So main.py. So the main.py is a trigger that we can execute the entire pipeline. So the last was the model evaluation, and we can just stop with the model validation. So component name model validation, and this is the just a summary of the pipeline. So we need to import the model validation pipeline. So we can have from SR source code Churn dot pipelines dot data ingestion validation. So this is, we did not include the model evaluation one. So let's include the model validation first. Then import a model validation pipeline. Then we need to also import something that we are missing, all params. Validation config, yeah, something we are missing. Let me just add the src pipelines. So this is the pipeline number 5, model evaluation. We are going to import model evaluation pipeline. And I think model trainer model evaluation component here. So let's check this error. So as no attributes all params. Model validation. Oops, so since we included the all parameters, then we also need to include that. So I'll just go to my model evaluation, and we need to include the all parameters, all params. So just go to trial, then we also need to include this one here. So we just copy this. We're supposed to include the same in the config entity. So all params, we also need to include this params as a dictionary here. Then we also need to update our configuration manager. So whatever we had here as all params, we also need to include that here, because we are tracking the parameters. Model validation config. Then for the trial again, we also need to include all params here. And we also need to include all params in the model validation. We also need to include in the trial one, yeah. So I think that's what we are getting with the error. So I can just run this again. Yeah, so while that is executing, then we can just go to a prediction pipeline. So with the prediction pipeline, then now we can import the necessary libraries. So we're going to import numpy as np. We're also going to import pandas. Also going to import os. Import sys. Then we're also going to import the logging, and I think we created an exception handling, so to raise custom exception. So we're also going to import that during the prediction pipeline. Before we continue, I think this one is okay now. I think it's okay now. So we sorted that error. Then when we go to our Dagshub, then we have experiment number 13, model evaluation. This one failed, so I just delete it. So we go to evaluation, model evaluation. You can now see now we are tracking. So if we do a comparison between this and this, then we compare, you can see that the first one we were not tracking the hyperparameters, but in the second one, as you can see, we are tracking the hyperparameters. I think we'll use the second one because it's good to know which parameters that we are dealing with. But you can see nothing changed in terms of the metrics because we did not alter the hyperparameters in any way. But that's it. So I think you have seen how we can track our model evaluation. So let's just go to a model prediction and sort it out. So model prediction essentially just handles the data, the user input data. We want the data to be processed similar to how we processed our training data. And after that, we are going to make predictions or make an inference on those, on the user input data. So I'm going to import the logging, then custom exception, and then a function from utils so that we're able to load an object. That object, I think, will be the preprocessing object. So from S, so I'm going to import logging. I'm also going to import, I created a custom exception. So from here, I'm going to import it. I just named it file operation error. File operation error. Then I'm also going to import a function, the load object function from utils. So again, from C Churn utils from the commons. We're going to import the function load objects. Then I'm going to create a new class. So prediction pipeline. Prediction pipeline. Prediction pipeline. Underscore self. Then for this one, I'll just pass. Then I'll create a new one. So this one was just about the initializing. Then from here we make predictions. Then data will be basically the features, not the labels for this case. Then I'll just work within a try block. Then this one will be the except. This will be exception as E. Then we created a custom exception, so I'll be using that. So rise, this will be the file array operations. This one here, and just use this. Just kill all the terminals. File operation error. Then just for this pass, and just do away with this. Then and first log a message. And for this message, you can now using the logging. Logging dot info. Here we can specify the message. Then we can say making predictions. Making predictions. And making predictions. Then we specify the model path. So basically we are now importing the model. So os.path join, then we can specify the path. So the path is under this artifacts, and the directory model trainer. This is also another way that you can import your objects or artifacts. Then the name of the model is the model.glib. Then we also include the preprocessor path. So the path to preprocessor. So this is the preprocessing that will preprocessing object that will preprocess the user data before making the predictions. Then after we are done with that, we can then load the preprocessor and the model object. Just do a little bit of tidying things up. So we can just do away with the things that are unnecessary at this moment. Yep. So we are loading the preprocessor and the model object. So we provided the path. So from the path, we're just extracting that. So preprocessor object, this is the preprocessor object. The model path, again, this is the model path. Then after we have done that, we needed to now transform the features similar to how we transformed our training data. So it has to be in a similar way so that we are consistent with the outputs that we will be generating from the user data. So that's why we are just using the preprocessor object, and we are feeding in the features. The features are the input data from the user. Then from there, then we are, after doing the preprocessing, then we are just going to apply or make predictions or make a reference based on the user input. Then from there, we can convert the data into a number 64 for a JSON serialization. Okay. Then after that, we can now return the predictions. Okay, so since we are going to use Flask, then there's a way that we need to handle the user data before we do the preprocessing and making the predictions. So we are going to create a new class, custom data, and under this class, we'll be receiving that data. Then we use this function to transform that data into a data frame so that we are able to now do the preprocessing and making an inference from that. So we convert that data into a dictionary. Then we return something like a pandas data frame so that making these predictions becomes easier. Then I've just used the custom exception that we built. So that's it. So that's it with the model. That's it with the prediction pipeline. So basically, this is just to handle the user data. Take the user data, transform that user data the same way that we processed our training data and making the predictions. Then from the Flask app, it will take these predictions, then display on the user. So that part on that will be coming in the next section. In that section, I will show you how to build a Flask application, a simple web application. We build using the Flask and also create a dashboard using Streamlit. So I'll try to maneuver between those two and show you that. Also, I will be integrating integrating that component with the mail trap. So we'll be trying to send messages to the different users, because we'll try to integrate sending user some brief message depending on their churn score. So we'll also try to integrate mail trap into that, and also we'll be saving the output from that from the prediction output in a new database. I think the cockroach, using the cockroach DB. So we'll be using this now. After making predictions, we need to save that data in a new database. Okay, so that it will be necessary for us to retain the model now with the new user data, input data. So that entire process, or the entire steps, we'll be doing during the next session. So this moment, stay tuned. So before we sign off, let me just push this to Git. Do a git status to see which files we are committing. Yeah, no problem. Then from here we can commit and specify that this was the model validation. And now let us push -u origin main. So that's it with today's session. So stay tuned in the next session when we include the other tools that I have mentioned. I've just mentioned. So I'll show you how to integrate those tools during. I think that will be the final phase of this project. Once again, thank you for your time. Thank you for finding time to watch these videos. Subscribe to this channel if you haven't. Share this with your friends. Like this video on your way out, and see you in the next one. Have a nice time.